Okay, so today we're going to look at inequalities, and the first thing we're going to do is just recap the inequalities that we did at GCSE, and they were all called linear inequalities because they all involved a linear equation. So in other words, only an x to the power of 1, nothing more than that. So I'm going to go through about 5 examples, and then I'm going to get you to do some just as a quick recap, because we do have to do these in A level as well, because these get mixed in with the more complicated inequalities. So I need to make sure that we're comfortable with these first. So as we remember from GCSE, we can treat an inequality equation just like a normal equation, and it follows the same rules of algebra. So whatever you do to one side of the equation, you have to do the same to the other. Okay. And so I'll go through a couple of different types of examples. So the first one's got a brackets in it. So quite often I would typically expand the bracket first. So I'd have 3x plus 6, because remember you've got to multiply everything that's inside the bracket with the 3 is greater or equal to 10 minus 2x. Okay. If that had been an equals, we'd just think we've got to get all the x's on one side and all the numbers on the other. So I'm going to add the 2x to both sides. So I've got 5x plus 6 is greater or equal to 10. I'm going to take away the 6 from both sides. So I get 5x is greater or equal to 4. And then I'm going to divide by 5. So I'll just get x is greater or equal to 4/5. Just leave your answer as a fraction. Don't bother with decimals. Okay. Next one, a little bit more complicated, because this time we've got a bit of a fraction involved. And if we look at the left hand side of the inequality, all of that is divided by 2. So you've got the 3 take away x, all of that is divided by 2. And my philosophy is, whenever you're solving any equations, usually it's better to try and get rid of any denominators and deal with whole numbers. So that means I've got to multiply through by 2. And if you remember, the rule is we have to multiply everything by 2. Now, before I start doing that, because the right hand side is easy, because I'm just going to multiply everything by 2. But let's think about what this actually means before we go on. 3 minus x all divided by 2. Well, it actually means the 3 is divided by 2 and the x is divided by 2. So I can actually split it into the 2 parts. So when I do this multiplying by 2, it's going to cancel with that one and cancel with that one. So actually, what you end up with, you're just timesing that by 2. And so you're left with 3 minus x is greater than 4x plus 14. And effectively, you've multiplied every term by 2. Okay. And then again, I'm just gonna write it. I'm gonna add x to both sides. So I'm gonna get 3 is greater than 5x plus 14. I'm gonna take away 14 from both sides. So minus 11 is greater than 5x, and then divide it by 5. So I'd have minus 11 over 5 is greater than x. Or to say it the other way around, x is less than minus 11 over 5. Okay. Right, now another example where again we've got a fractional part. So I want to get rid of that denominator of 2. So I'm going to multiply through by 2. And remember, we've got to multiply every term by 2, just like we would if it was an equal sign. So I'd have 3x, because remember, this multiplying by 2 is just to cancel that denominator. Minus 10 is greater than 4x plus 2. Now, I want to speed things up a little bit, so I'm going to take the 3x away, and I'm going to take the 2 away as well, so that I'm doing the swapping of the x's and the numbers at the same time. So I've got minus 10 take away 2 on the left hand side, which is minus 12, is greater than 4x take away 3x is x. So I've just got x is smaller than minus 12, or minus 12 is greater than x. Right, now, before I go on to the last 2 examples that I'm going to do, there's one thing that is different when you're dealing with an equation as opposed to an inequality. And that is when we multiply and divide by a negative number in an inequality. And I'm going to demonstrate why it's not true. So 5 is greater than 2. That fact is correct. We all know that 5 is bigger than 2. So let's just multiply through by a negative number. Let's times by minus 3. Well, 5 times minus 3 is going to be minus 15. 2 times minus 3 is minus 6. But if that inequality stayed the same way round, I would say minus 15 or negative 15 is greater than negative 6. And we know that that is actually not true. So what we actually have to do is, if we ever multiply or divide by a negative number, we actually have to switch the inequality the other way round. Okay, and we'll just see if it's true. Let's do a different one. We'll do a division this time. So I know that 10 is less than 25. So I'm going to divide by minus 5. So 10 divided by negative 5 is going to be negative 2. 25 divided by negative 5 is going to be negative 5. If I didn't switch it around, well, that statement's not true because minus 2 is not smaller than minus 5. But when I do switch the inequality around, that is true because minus 2 is bigger than minus 5. Okay, so what you have is you have a rule that says you have to switch the inequality around. You have to change the direction of the inequality. So I thought I'd do a couple of examples where I'm going to make sure I end up with a negative number of x's. So with this one, I'm going to take away 3 from both sides. So I get minus 2x is greater than 4. And then I'm going to divide by negative 2. Because I'm dividing by a negative number, I have to switch the inequality around. And I get x is less than minus 2. Okay. The next one, I thought I'd add this in because we've got one of these in the examples that I'm going to get you to do a bit later. I've got two denominators in this with two different values as denominators, and I want to get rid of them both. You could do it in one go, but I'm going to show you how you could actually do it separately first. So let's try and get rid of this 3. So obviously I'd have to times by 3. And if I'm multiplying by 3, I have to multiply every term by 3. So I'd have 2 minus, well, what's 5x over 2 times 3? Well, it's 3 lots of 5x over 2, so that would just be 15x over 2 is less than 3. Now I want to get rid of the 2 that's in the denominator, so I've got to multiply through by 2. And I would get 4 minus 15x is less than 6. Okay, so now I'm at the same stage that I was with the previous example. So I'm going to take away 4 and I'll get minus 15x is less than 2. Divide by minus 15. So I'm going to get x. Because I've divided by a negative, I've got to switch the inequality the other way around. And it becomes minus 2 over 15. Okay. Now, one thing I should note is, if that had been a less than or equals to, then in your answer, it just always becomes less than or equals to. But then when you switch it around, it becomes greater than or equal to. Okay. You just keep it the same sort of symbol. So whether it's a strict inequality, which is a less than or a greater than, or a not strict inequality, which is less than or equal to, or greater than or equal to. Okay, hopefully that's just a quick recap. So I've put 8 there for you to have a go at. If you want to only do the more complicated ones, that's okay. Press pause, have a go, and then I'll show you the answers. Okay, so number 1, expand the bracket first. Get the x's on one side, numbers on the other, and hopefully you add x is greater than minus 1. Second one, got to get rid of that denominator, and because that denominator is over all of the right hand side, when you multiply by 2 you're just left with x plus 1. So you've got 4x minus 6 is less than x plus 1. Again, x is on one side, numbers on the other, and hopefully you got x is less than 7/3. Right, number 3. So multiply every term by 5 to get rid of that 5 in the denominator. Get the x's on one side, get the numbers on the other, and hopefully you got x is less than 20/6 or 26ths. You can, if you want to, write that as 10/3 if you wanted to simplify it, or even write it as 3 1/3 or 3 2/6, that's fine. But unless they've asked for it in its simplest form, you really don't have to. Next one, straightforward. X is on one side, numbers on the other. Right, so number 5, I've done it this way to show that you've got to remember when you're dividing by that -3, you need to reverse the symbol, okay? You could have decided to add 2x and get the x's on the other side of the equation to avoid that situation. But you should have ended up with the same answer, x is greater than 2, whichever way round you do it. And for the next one, number 6, again expanding that brackets, and you should have got x is less than 3. Finally, last 2, multiply every term by 4 for number 7, and then again remember if you've ended up with that -3x, you've got to reverse the symbol. And the final one, I multiplied through by 2 first, then multiplied through by 4, and rearranged and got x is greater than 5/2. I did simplify that one. Okay. Right, so hopefully that's just a quick recap. Now, what we've got to do at A level is to think about inequalities in other types of equations, so not just linear equations anymore. And the one that we do at A level is quadratic equations. And we might even do a bit of cubics, but we'll do that a bit later on. And we've got to think what this means. So it says solve the equation x squared plus 5x plus 6 is less than or equal to 0. And what that means is for which values of x, when you substitute it into x squared plus 5x plus 6, gives you an answer that is less than 0. And you're thinking, well, I don't know if there's any, because you start putting, well, if I put x equals 1 in, that's positive. If I put x equals 2 in, it's going to be positive. But there will be, or there possibly will be, some numbers that you could put in where when you substitute that value of x in, it actually gives you a negative number. And so what we actually do is we actually think about what the graph of y equals x squared plus 5x plus 6 will look like. And we draw a sketch of it. Now, this goes back to what we did a couple of lessons ago. So we've got to sketch the graph of that quadratic. Well, we know quadratics look like U-shapes or N-shapes, depending on whether they're a positive or a negative quadratic. Okay, and we know the 3 things we need to be able to plot them is to work out where it crosses the x-axis and where it crosses the y-axis. So that's what we've got to do. And that's what we always start off doing. So straight away, we know it crosses the y-axis when x equals 0. And so that is when y equals 6. So that's where it crosses the y-axis. For our x-axis, we know it crosses the x-axis when y equals 0. So it crosses the x-axis when my x squared plus 5x plus 6 equals 0. Now, usually these aren't that complicated to factorise. And in this case, we're just going to get x plus 3 and x plus 2. So we can say it's going to cross the x-axis when either x equals -3 or x equals -2. So if I were to draw that, I've got my -3, my -2, and not very good, but you get the idea of what my quadratic looks like, and it looks like this. So this is the equation y equals x squared plus 5x plus 6. That's what the curve looks like. But I want to know, the question that I was actually asked was, solve the values of x for which x squared plus 5x plus 6 is, our best check here was, less than or equal to 0. So I want to know when the y is less than or equal to 0, because remember, y equals this. So I want to know where on this graph the y value is less than 0. Well, if I just think about that coordinate here, well, would the y value be less than 0? No, because it's above the x-axis. Let's do a different point. I'll get a highlighter so you can see it's a bit better. What about a point up here? Well, no, the y value isn't less than 0 because it's positive. It's going to be up there somewhere. So what about here, or here, or here, or here, or here? If you think about all the points down here, the y value is going to be less than 0 because your y values are all negative because it is below the x-axis. So for what values of x is my y value less than 0? So I'll say that again. For which values of x do I get a y value that is less than 0? Well, it's actually any of the x values that are in between -3 and -2. Because if I said choose an x value of -2.5, my y value would be negative. If I had an x value of -2.1, my y value would be negative. If I had an x value of -2.99, my y value would be negative. So the inequality is solved when my x is between -2 and -3. Now we have a way of writing that mathematically, okay? And what we say is if it has to be between -2 and -3, we say x has got to be bigger or equal to -2, and it has to be less than or equal to -3 at the same time. It has to be bigger than -2 and less than -3 so that it's somewhere in this middle region here. Okay, and that's the answer. So if I were to put into this equation x equals -2.3, the answer to that would be less than 0. If I were to put in -2.793, it would be less than 0. Okay, right, I'm going to do 2 more examples then. So here's the second one. Solve 2x squared plus 9x is greater than 5. Well, guess what? Quadratic inequalities are just like quadratic equations. Really, you can only really solve them easily when it's equal to 0. So it's exactly the same with an inequality. We have to make it less than 0 or greater than 0. So the first thing we actually have to do is rearrange it. So I've got to take away the 5 and I get 2x squared plus 9x minus 5 is greater than 0. And what I need to do, I need to sketch. So I need to sketch the equation of y equals 2x squared plus 9x minus 5. Okay, so that's the first job. So on the y-axis, x equals 0. So guess what? Y equals minus 5. On the x-axis, y equals 0. So I get my 0 equals 2x squared plus 9x minus 5. Got to factorise this, okay? They almost always do factorise. So I've got minus 10, so it's just going to be 10 and 1, where the 10 is positive, the 1 is negative. So let's do my method that I always use, which is my reverse grid method. So I've got my 2x squared, my 10x, my minus x, and my minus 5. So I'm going to have 2x there, x there, a 5 there, and a minus 1 there. So I'm going to have my 2 brackets are going to be x plus 5 and 2x minus 1. So either of those brackets equals 0. So either x equals minus 5, or I'll do the other one a bit longer. 2x minus 1 has to equal 0 because the second bracket has to equal 0. So 2x must equal 1. So x must be a half. Right, why did I do that? Only did it to draw the sketch. So I need to draw my quadratic. So here we go. It's going to cross the x-axis at minus 5 and a half. Okay, I'm just going to draw it. I'm never very good at drawing these, but it doesn't really matter. And it crosses the y-axis at minus 5. So this is the graph of 2x squared. Is it plus 9x? Can't remember. Yep. Plus 9x minus 5. And I needed to solve the inequality 2x squared plus 9x minus 5 was greater than 0. So in other words, I want to know the region when the y value is greater than 0. So let's think about it on our graph. The y's are greater than 0 any point along here. So you've got all the points from here onwards, but also they're all greater than 0 over here as well, because the y values are all positive over at this side as well. So all these have y values that are greater than 0. So if I put in an x value of 1, I'd get a y that was greater than 0. If I put an x value of 3, I'd get a y that's greater than 0. So all my x values to that side and all my x values to that side would give me a y value that is greater than 0. So what does that mean? My x has either got to be less than minus 5 or greater than a half. Now how do we write that mathematically? What we write is x is less than minus 5 or x is greater than a half. Now we have to write these as two separate inequalities because no number can possibly be less than minus 5 and greater than a half at the same time. So they have to be written separately. Whereas in the previous example, our number can be bigger than minus 2 and less than minus 3 at the same time, such as the number minus 2.5. And so because this is between two values, we write it as one inequality. So when we have a range between two values, we write it as a single inequality. If our answer is separate, two separate regions, we must write them as two separate inequalities. Okay? Right, one final one. So sometimes they actually phrase the question a little bit differently. They don't just say solve. They'll say find the range of values for x that satisfies the inequality 7 minus 6x minus x squared is greater than 0. But it comes down to the same thing. We've got to basically sketch. We need to sketch y equals 7 minus 6x minus x squared. And we need to find the range of values for which the y value is greater than 0. Now, one thing to note when we do this, it's a negative quadratic. So what does that mean? It means it's not going to be a U shape, it's going to be an N shape, okay? But we follow the same process. We still need to find where it crosses the x-axis and where it crosses the y-axis. So y-axis, I always start with that one because it's the easier one. My x equals 0, so my y equals 7. And on the x-axis, my y is 0, so I say 0 equals 7 minus 6x minus x squared. Now, factorising negative quadratics is never easy. So it's not never easy, but it's more difficult than factorising quadratics with a positive x squared. So I personally always multiply through by -1. So it becomes, all the signs change, x squared plus 6x minus 7. Because that becomes negative, that becomes positive, that becomes positive. Okay. And in this case, again, these are usually not too bad to factorise. I need two numbers that multiply to make -7 and gives me 6. So it's going to be a 7 and a 1. And it's going to be a +7 and a -1. So either x equals -7 or x equals 1. So drawing my sketch. So I've got my -7. I've got my +1. I know it's a negative quadratic this time, so it's going to look that way round, and that crossed at 7. And so this is the sketch of y equals 7 minus 6x minus x squared. And the inequality I wanted to solve was 7 minus 6x minus x squared, let's check, is greater than 0. So I wanted to know when my y is greater than 0. So again, getting my highlighter out, it's all these points up here, it's all the points where the y is greater than 0, so the y is in the positive half of the axis, it's above the x-axis. So my range of values are these values of x going between -7 and 1. And because we're going between two values, we write it as -7 is less than x is less than 1. Okay. You can write it the other way around. 1 is greater than x is greater than -7, but I don't tend to like that. I tend to like -7 is less than x is less than 1 and just go from left to right. Alright, I think I've spoken a bit too much now, so there are 5 for you to have a go at. First 2, straightforward, just the factorising is slightly more complicated. Third one, remember how to factorise those ones, and then remember with the 4th and the 5th, you can only really solve inequalities that are equal or greater than or less than or equal to 0. And press pause, have a go, and then I'll show you the answers. Okay, so first one, again, got to do the sketch. So we've got to find where it crosses the y-axis, where it crosses the x-axis. And when we factorise, we end up with 2x minus 5 times x plus 1. So drawing our sketch, which is on the right-hand side, we've got -1 where it crosses the axes and 5/2. Now we wanted to know when the graph is greater than 0, when the y value is greater than 0. So because it's in two separate parts, it's not between two numbers, remember we write them as two separate inequalities. So either x is less than -1 or it's greater than 5/2. Okay, again, next one. It's a straightforward one, just the factorising is a little bit more complicated. But again, when you sketch it, you should have got the two brackets of 3x minus 1 and another bracket of x plus 5. So you know it crosses at -5 and 1/3. This time it wanted to know when the y was less than or equal to 0. So when it's below the x-axis, remember all these values, all the y's are less than 0. So it wanted this region here. Because it's between two values, we write it as one inequality. So -5 is less than or equal to x is less than or equal to 1/3. Okay. Number 3, again, got to do the sketch. So got to sketch y equals 2x squared minus 6x. Remember factorising this one, it hasn't got a constant on the end, so it's just a single bracket type of factorisation. So you end up with x equals 0 or x equals 3. You want to find the inequality is less than 0, so we need the region when the y's are less than 0. So again, it's between the two values, so you get 0 is less than x is less than 3. Right. Personally, I always make it a positive quadratic, so even though I've got to move two terms, it's better to move the 5x and the 14 to the left-hand side. Factorising is very straightforward with this one. So you end up with the crossing the axes at -2 and 7. The inequality you want after you've rearranged is you want your y to be greater than 0. So it's all these values on either side. So you need to write it as two separate inequalities. So x is less than -2 or x is greater than 7. And the final one, slightly more complicated just because it's got more terms in it. But actually, the final thing that you come up with is really quite straightforward. Factorising is straightforward, so you get either x is -3 or 4. And because you want when y is greater or equal to 0, again, you've got the two separate inequalities. So your final answer is x is less than -3 or x is greater than 4. You must remember to put this word or in as well, okay, when you're writing them as two separate inequalities. Next year, we'll look at a proper thing, another way of writing this in a thing called set notation, but I'm not going to do that on a video. I'm going to do that next year. Okay, and that's the end of today's lesson. Next lesson we'll carry on with inequalities, but we'll look at how we can combine different inequalities together. Okay.